In this video, we are looking at how to graph and transform radical functions. And here, a radical function is of the form a, and then the radical x minus h plus k. And to graph a radical function, we are going to use tables and your knowledge of transformations. So using the table, we are going to find x values which are convenient, that lie in the domain of the function, and then we are going to graph the function. To get the domain of a function, if you're given this equation, so x minus h must be greater or equal to 0. The parent, because you cannot get the square root of a negative number, so the parent function can be the square root or the cube root. So it can be stretched, shifted up or down, horizontally or vertically, or it can be flipped. Remember, A represents the vertical stretch or flip when it's negative. And then we also have the horizontal shift for H. K is a vertical shift. This is the parent function, and this is the way it looks like. This is how the parent function looks like. And you can see it starts at 0 and to infinity. Okay, so here we are given 2 square root of x minus 3, and that's what we are going to graph. So we are going to get convenient values. So let's start at 0. So when x is 0, we are going to get 2, and then we have 0. So this is the square root of 0 minus 3, and we get minus 3. Then we go to the next one. Let's plug in 1 because we can get the square root of 1. So we get 2 square root of 1 minus 3. And then we get negative 1. And then the next one, let's plug in 4 because we can get the square root of 4. Remember, you're looking for convenient values. So 2 square root of 4 minus 3. And we're going to get 1. And the next one, we are going to use 9 because we can get the square root of 9. 2 square root of 9. And then minus 3. And we are going to get 3. And then the next thing is just to graph it. So 0 matches with negative 3. And then the next point is 1, negative 1. 1, negative 1. And then 4, 1. And then 9, 3. And then all we have to do is connect the points. And that's our graph. So our domain is x. Our domain is x greater than or equal to 0. And then our range is y is greater than negative 3. Y is greater or equal to negative 3 because that's the lowest that it goes. Okay, and the transformation. Here the transformation is vertical stretch. So I'm going to write it right here. So we have vertical stretch. Vertical stretch by a factor of 2. And that's because of these 2 right there. And then the other transformation we have is 3 units down. 3 units down, that's a vertical shift. Okay, so those are the transformations. Okay, the next one we have negative square root of x plus 2 negative 1. So to do this one, we're going to, again, we find convenient values for which we can get the square root of. So the convenient values will be the ones we are going to find any x value which when we add x to it, we can still get its square root. It becomes a perfect square. So let's start with negative 2. So we start with negative 2. And then here I'm going to write negative. And then here we have negative 2 plus 2 minus 1. See, that's the square root of 0 minus 1. So we get negative 1. And the next one, we are going to use negative 1. And this is going to be square root of negative 1. And then plus 2 minus 1. And that's going to give us square root of 2. Just negative 2. And then the next one, we're going to plug in 2. Then we get 2 plus 2 minus 1. And that will give us negative 3. And then the next one, we're going to plug in 7. Because when we plug in 7, we're going to get 7. We're going to get 7 plus 2 minus 1. So square root of 9 minus 1. And so 3 minus 3 minus 1. So we get negative 4. And all we have to do now is to graph it. So negative 2, negative 1. And then negative 1, negative 2. And then 2, negative 3. And then the next one is 7, negative 4. And 7, negative 4 is going to be 7, negative 4 right there. And now all we have to do is connect. And that's our graph right there. And let's write the domain. So the domain is going to be all the numbers less than x is greater than negative 2, greater or equal to negative 2. The range is going to be from negative y is less than or equal to negative 1. And the transformation, so here we're going to write the transformations here. I see 3 types of transformations. So the first one is it goes to the left. Left, how many units? This is 2 units. So we can say horizontal shift to the left 2 units. The next transformation is 1 unit down. So that's a vertical shift, 1 unit down. And then the next one is a reflection. Reflection over the x-axis. So those are the transformations. So here we have to find the cube root, and we need to find values of x, which when we add 5 to them, we can still be able to find the cube root. They have to be perfect cubes. And thinking about those values, let's start with negative. So we have to add 5. So let's start with negative 6. So when I put negative 6, this is going to be cube root of, so negative 6 plus 5, negative 1, minus 2. So what are we going to get? So it's going to be negative 1, so negative 3. So So we get -3. And then what other value can we put? Let's put -5, because that's another good value of x. So because that's going to give us cube root of -5. So cube root of 0, -2. So we get -2. And what other value can we try? -4. And then -4 will give us cube root of 1, -2. So we get -1. And what other value is going to be good for us? So we can try, let's try 3, because that will give us 8. So we get cube root of, so 3 plus 5 is 8, minus 3. So that will be 2, and not minus 3, but -2. So 2 minus 2, so we get 0. Now we can graph our values. So -6, -3, and then -5, -2, and then -4, -1, and then 3, 0, 3, 0 right there. And then it's also good to know how the function looks like. How the function looks like. Okay, so that's how the function is going to look like. It's not perfect. It's actually supposed to be going a little down here, but it looks like so there is some inflection over here, and that's how it's going to look like. So the domain is all real numbers, so all real numbers from -infinity to infinity. That's going to be an open interval. And then the range is the same, -infinity to infinity. And the transformation is 2 units down. 2 units down. And we also have 5 units to the left. 5 units to the left.